any questions from what was not on the quiz? 5-2? Is this thing on again? Am I echoing?
Yes.
Yeah.
Now I'm not, right? Not echoing. Okay, cool. Sounds very strange up here. So I believe 5-2 was not on the quiz, right? So anything from 5-2? Any questions? Because that's due tonight. No? Nothing? We're good on 5-2? What about 5-3? It's also due tonight. Anything? We're good? I'm gonna ace this test. Yeah, okay. Then what about the practice test? Any questions in there? Any problems you want me to do?
Can you go over logs a little bit?
Sure.
Yeah, that's like 10 questions today.
Tell me a couple. Oh goodness. It's already pre-maximized for us. Okay. I think the log stuff is at the end more, isn't it? Yeah, so I'll just go to the end and work my way backwards. How are we on this? Good?
Well,
Sure. So what do we notice?
Same base.
Same base. So what can we do?
Equal them. Well,
Equal what?
the square root x and
The inside.
Inside.
Okay, what now?
Square root.
We don't like the square root, so we square both sides. So we have x equals 121, and that's it, right? Because, can we plug it in? Yes. It's positive, essentially, because it's going into a root inside of a log. So it's like doubly can't be negative. Okay. This is pretty much the same thing, right? Just with a little extra solving at the end. This is putting it into a single log. Are we good at this? Do we want to see it? Yeah? Okay. Okay. So then what's our first step? What should we notice first, actually? Let me backtrack. That it's addition and same base. So we notice same base and it's addition. But what do we also notice? The coefficients. Yeah, we can't do anything with the addition and same base yet, right? Because we have those coefficients. What can we do with coefficients?
Put it as an exponent.
Put it as the exponent of the inside. So we have log base 5 of x to the 4th plus log base 5 of y to the 1/4 or
4 root of y.
the 4th root of y, right? Okay, now no coefficients, so we can actually do something about that plus with the same base, right? So what does plus do?
Multiply the
Multiplies the
exponent or the
insides. So we have log base 5 of
x to the 4th
x to the 4th
then
times the 4th root of y. Yep. And that's it. That's all we can do.
do you not do y to the 1/4? Like, do you have to
Technically, they're the same thing. However, I believe
like, it wants you to like put it in that form with the root?
Just type it in and see.
Sure, why not? Helps if I actually. Oh shoot, didn't want to do it that way. Just kidding, I forgot. Because we wanted to see if this works. We're doing an experiment.
No, I'm saying.
Okay, so yes, you can leave it as to the 1/4 power.
So that is fine.
That's fine, yeah. And because I'm now saying that it's fine, if it's not fine, tell me and I will fix it because then that's on me. Okay? Okay, so this is even more so, just the same thing, and simpler even. What about these? How do we do with these? We know that it goes to subtraction. Yeah? And then we know that 4 to the, what
Second.
power is 16?
The second power.
To the second power. 4 times 4. I knew what you were doing. That's why I was pushing it. So the first term, because it's in the numerator, is just 2, and then log base 4 of x. Okay, and then this is the same thing, just with multiplication, so addition instead of division to subtraction. What about these? Do we remember how to find domain of logs?
Is it the
You
inside?
want to do this one? So, what's the issue with logs? The inside has to be positive, meaning it can't be negative or 0, right? So, how do we find out when that happens, or when it doesn't happen truly? Greater than 0 for just the inside, yes. Now remember, not greater than or equal to, because it can't be 0, and don't set it equal to, because you have to know which direction is the positive side, right? So, set it up this way, and then solve for x. So we get negative 8x is greater than 5, so then x is less than negative 5/8. So, how do we write that in interval notation?
Negative infinity.
Negative infinity to
Negative 5
negative 5/8. All parentheses, right? Domain and range. For exponentials and logs are always just parentheses. You never get the inclusive on the ends. Okay? Because it's either always infinity or the number that's where the asymptote is. Okay? All right. Another domain. Now we're actually finding the value. We're good at that? Bless you. Yeah, we're good at this one? Okay.
Oh, I said this is negative 2.
Was the answer negative 2? 0, 2, yes. What about this one? What's the answer? 1/4. Because it's a root. And we can convert basically from exponential to logs.
Log negative 2 5
Base 5 of the answer equals
the
the
exponent.
exponent. So it's base that, right? You go back and forth sides kind of thing. Okay. And same kind of thing. And then we're getting into exponentials. Anybody want to see anything in the exponential portion of this review? No? We're good?
Good.
This one? Specifically? Okay. Alright, so if we're told that we have this equation set up, and we're told that the E. coli can double every 20 minutes, then the initial number of E. coli is 3. How many will be present in 3 hours? Okay, so remember that the n base O, or 0, is basically the original initial amount. okay? What the starting unit. So we have n of, well, we're going to plug in 3 hours for t, so n of 3 is equal to 3 for the number of initial, it's just coincidentally the same number, not always. Then 2 to the 0.05 times 3 for t, and then we plug that into the calculator. I have no idea what that is. I'm sorry? Oh, is it in minutes?
Yeah.
It is in minutes. Good catch. So, we're told hours, but the equation is in minutes. So 3 hours is how much in minutes?
60 times 3.
60 times 3, so 180, right? Okay, now we plug that in, and I really don't know what that equals. 8, 20, and that would be 2 would be 10, 90. 2 to the 9th, and then times 3, and yeah, I don't know what that is. What is it? 512? And nearest whole number is needed. So remember, 5 and above round, 4 and below do not. Okay, and then we're told if the initial number of E. coli is 7, how many bacteria will be present in 3 hours? Well, guess what? We can just exchange the 3 for a 7. So, right? If you have one of the calculators where you can go back up into what you just typed, just replace the 3 with 7, and then you don't have to retype it all again. And that saves you a lot of time. Okay? Then, if the initial number of E. coli is 7, how many bacteria will be present in 5 hours? So again, we can just do a replacement again. 5 hours is how many?
300.
300, yes. Okay, and then again we get whatever the change is. Okay? So just knowing kind of what all the pieces are called and watching for the units, making sure the units are the same, because we almost went down the hours to minutes road and that was going to get us into the very wrong place. Okay? They like to do that sometimes, so be careful of that. So, were there any others that you would like to look at from the review? Yeah?
The one with the minus sign that you said would be easier, what do you actually do with that one?
The one with the minus sign that I said would be easier?
Yeah, it's like 20 something. No. No. Yeah.
Well, because this is just division of the insides, right? 28 divided by 7 is just 4. So it would be log base 2 of 4. And then 2 squared is 4, so the answer is just 2.
Okay.
Does that make sense? Do you want me to write it down?
Yes.
I do. I should write it down? Okay. So, on this one, because it's subtraction on the outside, we can divide the insides, right? So we have log base 2 of 28 divided by 7, right? Which is 4. Then, what is that, right? What does that log equal? Remember, it's 2, so what equals 4? 2. That's it. That's our answer. It's a long, fancy way of writing 2, basically. Question? I saw.
No, I have a question. I know someone else has this issue, but I thought it was crazy before, but I'm almost positive now. I'll put answers in the test or the quizzes, and when I review it, it's not the answers that I put.
So sometimes I've seen the question change. So like if you're in it, like in the practice test, and then you close it and come back to it later, but you didn't do anything to that question, you just wrote it down or something, it will change the question.
It's the same
Anything else from the practice test? Are we good on here? Yeah?
So when you did, okay, wait,
That's okay.
no, go please, I didn't see you.
I was just gonna say, could you do first one?
The very first one?
Yeah.
All right, sure. Okay, so we have a baseball player and he swings and hits fly ball. What? Okay, he hits the ball straight up in the air to the catcher. Okay, it literally just goes up. Okay, then the height of the baseball is given by this equation where h of t is the height in meters and t is the time in seconds. How long does it take for the baseball to reach its maximum height? How do we find maximum heights? Vertex. When the parabola has a what type of leading coefficient? Negative coefficient, right? Because that means the parabola is going down, so then it has a top, right? It's the only way it can have a maximum. So we want to find its vertex. How do we do that? What's the formula? Negative b over 2a. So x is equal to, in this case, negative b is negative 14.7 over 2 times negative 4.9, and whatever that is, I don't know. I'm no good at decimals or even big numbers like that. Because if you got rid of the decimal, it'd be a big number. It'd be 147. I don't know how to do anything with that in my head. So, what does this equal? So we have to use it. So, 1 decimal place. Rounded, what was it?
It's a
9.8, okay. So, and it's positive, right? We have 2 negatives, and it's, technically this is not x, this is t, because it's the time.
Yeah, the bottom is 9.8.
Bottom is 9.8, yes, I agree with that. I thought that seemed a little clean, but, okay, so bottom is 9.8, negative technically, or you can just get rid of the negative on the top as well. Either works. Positive answer, basically. 1.5. Okay, I like that much better. So it takes 1.5 seconds for the baseball to reach its maximum height, right? So how do we find what the maximum height actually is?
Plug that in.
Plug that in, yeah. So literally just plug it in for t. Okay? That height value would be the maximum height. Okay? We do a lot of this kind of stuff with the business problems as well. So make sure to remember all of those formulas and how they connect. Do you want me to write those out?
Yes.
Should I write those out? I thought so. Let me give myself more room. Are we done on here? No more questions on this? So I'm gonna turn it off if we are. One of the business ones? Sure. Let me find one.
Do the one with all 3.
The one with cost and revenue and profit? There. Is it this one? No, that's just revenue.
I think it had all
It
of
had
the
all
top
3,
to scroll A, down. B, and C.
No, the questions are listed right here. It's how much should we charge, maximum revenue, maximum revenue, maximum revenue. A whole bunch of revenue. I mean, it gives us stuff, but it doesn't give us profit or cost.
That's not on there.
Yeah, I don't think it is because it would be with it right here. So I can write out the connections after we go through this problem. How about that? Okay, so how much should be charged for the television set if there are 90 in stock? Well, I have to scroll down to get the formula. That's helpful. Okay, so we're selling 90. What do we do? Plug in 90. Literally, yeah. So the price, remember lowercase p, negative 0.13 times 90 plus 143. So Want to help me out? What's that equal? $131.3. Okay, so there we go. If we got a whole long big decimal that kept going, because it's money, make sure to round it 2 places, right? Okay, then we want to know what quantity of X will maximize the revenue. So what did we just say? How do we find the value that maximizes? The vertex. But we have to find the revenue equation first, right? So remember that price times X, so price, and this is quantity, is R of X, or revenue, right? Okay, so then revenue is equal to negative 0.13 x squared plus 143x, right? So now we can find the vertex. That means that x is equal to negative 143 over 2 times negative 0.13. Which is 550. Okay, this is a quantity that maximizes the revenue. So remember, revenue is the maximum amount of dollars that we bring in by selling product, right? We don't keep it all, but it's the max that we can bring in. So now, what is the maximum revenue? How do we find what the actual amount that we bring in is? Plug it in, yeah. So just find R of 550, right? Whatever that is the max revenue. Okay. Then, what price should be charged in order to maximize the revenue? What do we do there? Plug the 550 into the price equation. So P equals negative 0.13 times 550 plus 143. And that equals a dollar amount. Okay? So then after that we have C of X, which is the cost equation, right? That is usually some cost amount, some dollar amount times X. Okay, or they just give it to you. This is if you have to write it yourself, but if they just give it to you, well, you don't have to do anything to it, right? Then the only other one that we have is profit. Remember, this is capital P. Okay, I didn't give myself a here there. Capital P, and that is, how do we find profit?
Revenue times cost? Or so
revenue minus cost, because remember, it's the money that we keep. So it's the money we bring in minus the money we pay out. So revenue minus cost. So those are all the different things that we can be asked for. We're given price, X is quantity, multiply them to get revenue. Cost is either given or you multiply literally the dollar amount times X. Then profit is revenue minus cost. If you are starting out all the way with price and you need to go to profit, you got a couple steps to go, right? Just make sure to label everything, because then you will need to go back into different parts of it. And if you don't know what it is, you have to find it again. And well, that just sucks, right? Okay. Any other questions on this? No, we're good? Okay. So, I think we can then go ahead into the actual material next for 5.4. Also, I have been meaning to say this. right? With a night class that has a lot of students, as a professor, you just learn to expect a slightly lower average overall. I'm really proud of y'all because the last couple quizzes, we've had really high averages. Quiz 7 was an 87 average. Quiz 8 was an 83. We've had quite a few others in the 80s, okay? That's awesome. Even in daytime classes, I've not had that. So, give yourselves all a pat on the back. You're doing really well, okay? So, yay you. Okay, now on to 5-4, which is actually kind of using logs and exponentials in solving equations, okay? So now what we want to think about is how do we solve equations when we don't have all the same base? So if we're given something like 2 to the x equals 3, what do we do then? Right? We can't just say, oh, same base, set the exponents equal. We can't do that anymore. So we have a couple options. Any ideas? Yes, we use logs because, well, we have our variable in the exponent. We don't want it up there. The only way to get it out of the exponent is to use a log because it's the inverse. What type of log, what base do you think we should use? There's 2 right answers. 10 is a really good choice because you have log base 10 in your calculator, okay? The other good choice is to use the actual base that's here, okay? If you do it that way, however, you will need to know an extra formula, okay? I will run through that at the very end just to show it to you so that you know that formula, but let's just use base 10 for now. So if we take log, just base 10, you don't have to write it, so just log of both sides. Then, what do? There is a log rule that helps us here. Yeah, take the exponent and put it down as the coefficient. We don't like it up there, that's why we used the log in the first place. So now we have x times log of 2 equals log of 3. Now this is just simple algebra. Just divide the log over, right? Just get x by itself. So we have log of 3 over log of 2. That we can directly put in our calculator, okay? How you would type it is the log gives you a parenthesis, put in the 3, close, divide, the next log, it opens, 2, and close, okay? If we plug that in, we get approximately 1.5850, okay? The other way of doing this, if we use base 2, so if we use log base 2 on both sides, the log and the exponential both cancel, right? Because they're both base 2. So then we just go directly to x equals log base 2 of 3. But we can't plug that in our calculator. So how we can change it, it's called a base conversion formula. Whatever's the inside goes on top. So we get log of 3, base 10, we're converting to base 10, over log of the base, which is exactly what we got the other way, okay? But that's a new formula, okay? Only if this way makes more sense would I do it this way. Otherwise, just use log base 10 because it goes directly into the calculator, okay? Any questions on either one of those? Okay, so then next is if we have 10 times e to the x equals 2. So what's going on with this one? Again, the x is in the exponent, right? So, we don't like it. On base e, go ahead and use ln because that is in the calculator. Yes, definitely use ln when it's base e. But we don't like that 10, right? Just divide it over to the other side. So what we want to do is get whatever exponential part on its own. Okay? So that means we have e of the x equals 2/10, which is 1/5. Now take the natural log of both sides, the ln. Because now natural log of e cancels, right? Because you have the e inside of the natural log, so then the exponent drops down, and we have the natural log of 1/5. And we can just plug that in. Okay? It should be on the same button as the exponential. And that is approximately equal to negative 1.6094. Okay? These are not too many steps, but you just kind of have to remember what to do with them. What about if we have 2 to the 4x over 3 equals 5? What about this one? You could use log base 2 again, but let's go ahead and do the other one just so that we don't have to use the conversion at the end. So if we do log base 10 of both sides, what next? Move the exponent down. So we have 4x over 3 log of 2 equals log of 5. Now, there's a few steps right now to get to the x. I would do them kind of in pieces. I wouldn't try to do too much at once. So at this point, I would divide the log over. So then you have 4x over 3 equals log of 5 divided by log of 2. Now, when we have a fraction on the x, just multiply both sides by the reciprocal. Yeah, just multiply by 3/4 on both sides. And to not confuse yourselves, do put the multiplication on the front of the log, not on the end, because we can't get to that 5 and 2, but you might forget, and then do stuff to it, and then it's going to make it completely wrong. Okay? So that means 3's cancel, 4's cancel, so we just have x equals 3 log of 5 divided by 4 log of 2. Okay? So, how you would want to type that in so that you don't have to do it in pieces, because then your rounding will be off. That would be open parentheses 3 log of open 5 close the numerator, divide by open the denominator 4 log of open 2 close the denominator. Okay? That will give you the exact answer, which is approximately 1.7414. Okay? Let's do one more of this type. So if we have 5 to the x squared plus x equals 25, what do we do? Actually,
You change 25?
change 25. Yeah, don't forget the stuff that we had before. Just because we added something doesn't mean we always have to use that new way. They're both base 5, as long as we rewrite the 25. So 5 to the x squared plus x is equal to 5 to the second. So then, what equals what? X squared plus x equals 2. So x squared plus x minus 2 equals 0. How does that factor? X plus 2 and x minus 1. So then x equals negative 2 and positive 1. And they both work. If we plug in negative 2 squared is 4, minus 2 is 2. That's 25. Plug in 1 squared is 1, plus 1 is 2. Okay? So don't forget our old methods just because we came up with new fancy log way. Okay? The old way still works. So the kind of opposite of this is if we start out with logs and then we want to use exponentials. So if we have 2, let's just do 2, log base 5 of 7 minus x minus log base 5 of 2 equals log base 5 of 50. What do? Combine what we can. So can we combine anything right away? No, yeah, we have to square this side because the 2 out front. Bring it up. So we have log base 5 of 7 minus x squared minus log base 5 of 2 equals log base 5 of 50. Now what? Divide the insides on this side because of the minus. So log base 5 of 7 minus x squared over 2. Right? Equals log base 5 of 50. Now what? Same base. So the inside's equal. So 7 minus x all squared over 2 equals 50. Then what?
Times 2.
Multiply the 2 over. So we then have 7 minus x squared equals 100. Yes, we can use the square root. Oops, I'm so bad at turning this thing. So we can use the square root formula rule. We take the square root of both sides. This cancels to give us 7 minus x equals
10.
not just 10.
Plus or minus.
Plus or minus 10. That's the only reason I don't like that rule. Okay, remember, when we do use that square root property, you have to get 2 answers there. So, then subtract 7 from both of them, right? So negative x equals 3 or negative 17, right? Okay, and then change the sign on everything because negative x. So x equals negative 3 and positive 17. Do they both work? Can we plug negative 3 in? 7 minus minus 3 is 10. That's positive. It's all good. What about 17? 7 minus 17. Negative 10. Bad. Doesn't work. Only negative 3 is your answer on that. Okay? Alright, so don't forget that 5-2 and 5-3 are due tonight and test tomorrow. Alrighty. Have a good night. When did I say you should come? I remember talking about it. I just don't remember what I said.
Question 4 is